everyone, welcome to this quick video tutorial. Today we're again going to be looking at how to use a Karnaugh map to simplify a logic statement or related to a logical circuit. I've drawn my Karnaugh map, and as before, we've got one of our inputs on one side with the two possible combinations, and then we've got our other two inputs on the other side with the four possible input combinations. Notice the sequence 0, 0, 0, 1, 1, 1, 1, 0, because we only want one bit change as we go through that sequence when we're drawing a Karnaugh map. Now let's have a look at a logic statement. The output is 1 if not A and not B and not C, or not A and not B and C, or A and not B and not C, or A and not B and C. So to get started, let's put these four sections here into the Karnaugh map. So not A, which is this row, not B, not C, which is this column, is here. Not A, which is again this row, not B, C, well there it is, not B, C, there we go. A, which is now this column, row, not B, not C. So let's put that there. And the last one is A, not B, C. A, not B, C. So now that we've populated our Karnaugh map, we need to think about how to simplify it. And what we could do is we could group these all individually. That would be absolutely fine. And then go through the process of determining the simplification. But we're not going to do that. We could group them in pairs like that. That's also fine. And then work out how to simplify the logic. We could also go horizontally and group them like that. That's also fine. We could do a wraparound, so we could group these two and these two. I guess that's a different way of looking at it, but that's also fine. Remember, we can't do horizontal. That's the only thing that we can't do. Okay, and we can't group a group that's not to the power of 2. So we can't group a group of 3 like that. Okay. What I'm going to do is just group all 4 of them. They're all together. 4 is 2 to the power of 2. So that matches the rule. Let's just do it like that. Now that we've got our groupings, we want to try and determine for each input what's going on here. So for input A, for this grouping, it can be either 0 or 1. That's fine. For input B, it's 0 here and it's 0 here. So it's always 0. So B is always 0. And for C, it's 0 here and it's 1 here. So that's either. Okay. So we basically want to get rid of our eithers. We can just cross them out, and we are left with not B. So to simplify this logic statement, the simplified statement is simply not B. Now before I finish the video, I just want to mention one more thing. If we had another one here, that maybe, or somewhere that couldn't be added to the grouping, for example, we could just have that by itself. So for example, I could just group that by itself, and maybe it can't be simplified, so this would be not A and B and not C. So we would finish the simplified logic statement by just ORing that situation. So not A and B and not C. Okay, so that would be the simplified logic statement if that was our solution to that problem. Okay, we could of course maybe do a wrap around here. Just do a wrap there and wrap it with this one. Let me just make that as clear as I can. Let's get rid of that. And let's do that. And let's delete that. So another solution to this problem would be to include it with a partner. We could do a wraparound. Say, okay, I want this one to partner up with this one. And then I could figure out the simplified logic for that group as well. Okay, that's a very brief continuation of our study of Karnaugh maps.